Okay, I had to watch a video about the world's largest magnet. This magnet sucks objects, it generates electric currents, and it levitates non-magnetic objects. And it also wreaks havoc on camera equipment. This just means that, like, you can't record near it or, like, it'll mess up your camera. It is in Tallahassee, Florida. That is where it's located. The magnetic field of Earth, a little backstory. The magnetic field of Earth is 0.0005 Tesla. A fridge magnet is 0.01 Tesla. And an MRI is 3 Tesla. But the world's strongest magnet is 45 Tesla. If that, like, kind of like ratio-wise plans it out for you. The magnet has an outer and an inner magnet. It has a fringe field. This is just extended magnetic field, so if the magnet's here and you're all the way back here, the distance is the fringe field, basically. So that's why it still attracts so far away. You can't have any ferromagnetic items within the 100 Gauss line. This is just for safety reasons, I assume. I'm not really sure. Ramping up the magnet to full power takes around 3.5 hours. It's a long time. Because they have to put 47,000 amps of current into the outer magnet, and this is just more so why it takes so long to do that. Some history behind the magnet. It was founded in Greece in Magnesia, hence where the word magnet comes from. The mineral magnetite is what led people to discover the phenomenon of magnetism, because the minerals were attracted to each other. They were called lodestones when they were founded at first. They realized in China that the magnets could be used to make compass needles, because they would always point in the same direction. Okay, little scientific. Why are only some items magnetic? Electrons are tiny magnets. And to start, atoms with a filled shell are paired up, and with one pointing one way and one pointing the opposite way, so their fields cancel each other out, making it not a magnet. Atoms with a half-filled shell, where they can't pair up, creates a magnetic field, making it a magnet. Yes. When atoms have magnetic fields, and if neighboring atoms are not aligned, that makes it not a magnet, because all domains have to be aligned for the magnetism to take place. When different materials are put near magnets and then tilted the opposite direction of the magnet, the materials that conduct electricity fall a lot slower. So in the video, it was just the big giant magnet, and they took a metal sheet and they, like, different metals, and they just let them all go at the same time. And the ones that conducted electricity kind of like fell a lot slower. But then once they had that big sheet that was falling, whenever the guy in the video tried to push it down, like, with his hands, he was unable to, like, push it down. It was, like, I guess something about a south force was pushing, which made it difficult to push down. But when he tried to take it off, it was incredibly difficult, again, because of that force underneath the magnet that's pushing, and showed a lot of, like, arrows and, like, the motion or whatever of the, what I said before, the ferromagnetic field, or no, the fringe field. That's what it was. And then they took like a ball, like a metal aluminum ball, and they dropped it into the magnet. And when they dropped it, it was going fast, but when it hit, like, that field, it decelerated. And then they rolled a ball across it, and when they rolled it, it started slowing down when it hit the magnet. So I just realized that the magnet creates deceleration. And this is really what I learned about the world's largest magnet. Thank you.